So you have to go to this partitions tab, okay, and every sales group and every measure group will have one default partition, okay. So what is this partition, what is the use of this partition is, so here you can see I might have told you about this. Now let me tell me one more time. Translate. Now we are getting the data. So this is our SQL database, okay. This is our SQL database, okay, and this is our SSAS cube database, okay. SSAS cube database, and here we have created one measure group, okay. We have created one measure group, let us say for sales. Under that, okay, we have created one measure group called sales, so which is fetching the data from fact internet sales table from here, okay. So here we have one sales table, okay. So when you are processing, what is happening, it is going and connecting to this data table, okay, and fetching the data from SQL database to my this measure group, that is sales, okay. Suppose if this sales table contains, let us say, some 5 years data, okay, and each year data containing, let us say, something like 5 lakhs, okay. So each year data contains 1 lakh data, 1 lakh records, and since it contains 5 years data, so total number of records present in this table is 5 lakhs, okay, 1 lakh for each year, okay. So let us say that, so my SSAS cube solution, SSAS solution, maximum speed it can occur is, so 1 lakh records, okay, 1 lakh records, okay, for in 2 seconds it can fetch 1 lakh records, okay, in 2 seconds it can fetch 1 lakh records. Now, how much time it will take to fetch 5 lakh records? So let us say that 10 seconds. So let us say that 10 seconds. So it will take 10 seconds to fetch 5 lakh record. Now that is the fastest I can achieve. Now let us say that it contains 5 crore records. The total number of records is 5 crores. Okay. Then how much time it will take? So how much time it will take is, let us say that 1 lakh per second, no? So, 2 lakh, 1 lakh per 2 seconds, no? So for 100 lakhs, that is for 1 crore, how much time it will take? Into 2, that is 200 seconds. So it will get 1 crore data in 200 seconds. Okay. In 200 seconds means how much time it will take? 200 seconds means, so let us say 2 minutes. So 60 seconds is equal to 1 minute. So let us say almost like 4 minutes. Okay. Let us say near to 4 minutes. So 1 crore data will get it in 4 minutes. Okay. So 5 crore data it will take, how much time it will take? Into 5. Okay, that is 20 minutes. So it will take 20 minutes. If it has 5 crore data, how much time my SSAS cube solution will take? It will have 20 minutes. Suppose then if it contains 100 crores of data, so there is a chance of getting huge amount of data, no? So in so many tables, you will get the historical tables or some, since it is a transactional table, so there is a chance of getting 200. We lost, let us say 50 crores. 50 crores means how much time it will take into 10. That is 200 minutes. 200 minutes means how much? Let us say 3 hours. So if it contains 50 crores of data, then it will take, so instead of 100, let us say 50 crores of data. So if it contains 50 crores of data, then it has to wait 3 hours. Okay, 200 minutes, that is equal to near to 3 hours. Okay, so Even though my SSAS cube is getting 1 lakh per second, but when it has a huge amount of data, okay, like 50 crores, it will take 3 hours for processing time. For processing time itself, it will take 3 hours. So this is not acceptable, no? So the customer cannot wait. So suppose if you want to process multiple times in a day, okay, for small change also we have to process. If you do some small change in the cube, we have to reprocess. Suppose if you want to reprocess multiple times your cube in a day, then every time it will take 3 hours. Every time it will take almost near to the 3 hours. Okay. So will the customer will wait for 3 hours to get the latest data? No. So in order to improve some more performance, we have this partitions. Okay, we have this partitions. So in this partitions tab, what we will do is, so in this partitions tab, what we will do is, so we will go and write a, so suppose let us say that this 5 lakhs data contains for each year it contains 1 lakh data, no? So we will go and write multiple queries, not a single query. We will go and write one query for 1 year. So since it contains 5-year data, what we will do, we will put a query, multiple queries. So let us say if it having the 2005 data, to fetch the 2005 data, one query, and to fetch 2006 data, one query, to fetch 2007 data, one query, to fetch 2008 data, one query, and to fetch 2009 data, one query. So earlier, to fetch the 5 lakh records, it took 10 seconds. Now, to fetch the 5 lakh records, we are writing multiple queries. Not only one query, we are writing multiple queries. All these queries will get executed parallelly, okay, at the same time. Okay, then even though we have 5 lakhs data which can be fetched in a 2 seconds instead of 10 seconds. Which can be fetched in a 10 seconds. So if we have 5 crores of data, so let us say that, so if 5 crores of data, 1 crore data, let us say it took 20 seconds, then 5 crores of data also will get 20 seconds. We can fetch the data in 20 seconds. Even though if we have 50 crores of data, we can fetch it in 20 minutes. Okay, like that. So that is the use of partitions. Okay, it is like a just a simple example. Simple example is, suppose if you have a pot. Okay, suppose if you have a pot, so if you have only one hole, so let us say to empty this pot, so it has full of water. So if you have only one hole, how much time? Let us say it is taking 10 minutes. Okay, to empty the water. Now its partition is nothing but a putting a multiple holes this part. Then if to empty the water, now it will take less than a minute, no? So that is what is called partitions. That is called partition. What the partitions will do. Now let me see that. So let me go for practically. Okay. Now we are in the partition section. Okay, so here you can see by default every measure group will have one default partition. If you go for any measure group, one partition will be there. Like that for sales also one partition is there. Now this partition, this is my source table. Okay, you can see here in the cube structure, my transaction table name is sales. Okay, so that is what here also it is showing it as sales. Actually the sales means it is a packed internet sales table. If I go to the data source view, if I go to this, here we have one sales table. Okay, And if you go and see the properties of this, the sales table, it is a friendly name for the actual table fact internet sales. Okay. Now let me go back to this queue. Go to the partitions. Now here you can see the source is nothing but fact internet sales table. You click on it. Okay. Now first of all we need to see where it is binding type. Binding type is now it is specifying it as table binding. Table binding means table to table transfer. Right now it is happening the table to table transfer. Table to table transfer is this is SQL, this is SSAS. Okay. Right now it is going from this. We have one sales table and we have one sales measure. So right now it is doing table to table transfer. It is called table to table. So it has only one query. Okay. Now we have to change this. First of all, we have to change this binding type to from table binding to, we can see we have one option called query binding. So since you have to write multiple queries, no, now I am changing this to from table binding to query binding. Now you can see we are able to, now you can see this is fetching the data from fact internet sales table, and we have a filter condition where you can go and write our filter condition. Okay. So let us say that we have one where let us see, go to this table. You can go and directly write. We click on connect to my database, and go to this adventure works data warehouse. So let us see how many different years are there in my fact internet sales table. Okay, select to start. So let us say that distinct year of order date. Let us take any date. Okay. So we have an order date in this table. Okay. Let me see the distant year of order date. So now we have 4 years of order date. Okay. Now we can go and write a query here saying that where year of order date equal to 2005. Okay, so if we have, so it is the least year is 2005. The least year it is having is 2005. So I can go and write a query. So to be on the safe side, what I will do is instead of year of order date equal to 2005. Okay, what I will do is I will go and specify. So to fetch any records, if by chance if any records present which is having less than 2005 also I want to fetch. Okay, so I have written where order date is less than or equal to 2005. Why? Because this is the least year, no? That's why. Now click on OK. Okay, now you can see I have one partition, and partition name we can go and give sales underscore of 2005. Okay, so we have one partition here. Okay, now let me go and add new partition. Let me click on this icon, new partition. Okay, now go to next. Now measure group is sales. So this partition where you want to add, I want to add under the sales. Okay, and let me go for our sales tables. Okay, data source view. So we have multiple data sources. Okay, we have to look it on data source view, that is data source view adventure works. Now we can see the database for this measure group is data source view. Okay, it is not going for the underlying SQL table. Okay, now click on this find the tables. Okay, now we have available tables is sales. Go to next. So we are creating a new partition. So for the existing partition, I have changed it to query binding. Okay, and I'm fetching only the 2005 data. And in order to create a new partition, I have clicked here and I have for which measure you want to create a partition for sales. For this sales, your database is DSV AdventureWorks, and what is the tables present under this sales group? Now let us say sales. Okay, what is the measures present under this sales group? It is sales. Go to next. Now specify a query to restrict rows. Now select this. Once you select this, again one more query is coming, and here we have to write where year of order date is equal to 2006. Okay, where year of order date. Now I am fetching the year of order date is 2006. To next. Okay, and here you can see that processing and storage locations. Okay, so the processing location. So do you want to process on the current server? Yes, I want to process on the whatever the current server, whatever present server it is using. I want to use the same current server instance. Okay, or storage location. Storage location is after processing. After processing, where you want to store these 2006 data. So do you want to store it right now? It is all storing under this program files, SQL Server, MS SQL Server, OLAP data. So where it is storing is, you can go and see in your local server. So under the C program files, okay, under the MS SQL Server. So we have one, once you install the software, now we have one folder for storing the, now you can see SSAS MS SQL Server, OLAP, and we have one data folder. So now right now it is storing my SSAS cube databases in this location in my local computer. So every SQL server, okay, in SQL server you are creating a databases. So whether it is SQL database or analysis server databases, that is cube databases. Now this is the list of cube databases. No, so where actually the physical location of these databases? The physical location of these databases is this one. C program files, SQL server, okay, OLAP date. Now you can see we are whatever the databases we are created, all are coming here. Now you can see Abhi underscore SSAS. Okay, so this is the physical location of our cube databases. Now it is asking the same thing. So storage location. Do you want to store this data, okay, of 2006 here in the same location, or do you want to change the location? If your memory is full, you want to change it from into any other folder like that. If your disk space is full, do you want to store it in any other folder? Similarly, the processing location. The current server instance space is the same physical location it will process. Okay. Now, after specifying the locations, go to next. Now I'm selecting the storage location as the same location. Go to next. And do you want to design the aggregations now? Do you want to design the aggregations now? Aggregations is nothing but, so whenever you are dragging or dropping on the final output, so when you are browsing the cube data now, so you are dragging color wise sales or product wise sales or year wise sales or month wise sales. So whenever you are dragging, it is preparing the query on back end now. So in the behind, it is writing a query, it is generating the query for you. So do you want to write any predefined queries? Do you want to store some predefined queries? Then we will go for this aggregations. Now you can tell that no, I don't want to design in the now while doing the partitions. I don't want to design the aggregations. We have a separate tab for designing the aggregation. So we'll go and create there. I don't want to create it now. Then you can go for and select design aggregations later. Or if you want to design aggregations for this partition now, you can go and create. Or if you have already aggregations are designed for the existing partition, then you can select this option. Okay. So, but usually what I want to do is I want to design the aggregated queries in this separate tab we have. So I don't want to design aggregations now. Okay, finish. That's it. Now you can see it has created one more aggregation. Now we can go on one more partition for 2006 here. Now we can go on give it as sales underscore 2006. Okay, like that we have to create partitions. Let me create one more partition for 2 more years later. Okay, find tables. I have the sales table. Go to next. Specify query to restrict the rows where year of order date equal to 2007. Okay, go to next. Yes, I want to the same location I want to process and I want to store the data. Go to next. You want to design applications later, and if you want to give the name here, you can go and give the name here for your end. Let me go for sales underscore 2000. Finish. Okay, now you can see we are able to create three partitions. Let me go and create one more partition to text. So now you can see this is how we can create this is how simple to create a partition. So you no need to write a query, just specify the filter condition. Okay, it is switching from the fact internet sales. Now just go and specify the filter condition where of order date. Okay, now let us go and see. We have 2008. Okay, now where year of order date equal to 2008, and if by chance if it is record will come whose year value is greater than 2008, then you can go on right. So to be on safe side, we have to go on right greater than or equal to 2008. Okay. So if any new record is added, okay, which is greater than whose order date is greater than 2008, it will also get fetched. Okay. Now go to next. Specify the same location, and I want to design the applications later. Now put it as sales underscore 2008. Finish. Now you can see. So this is the 4 partitions I have created. Okay. Now that's it. So since we have created 4 partitions, and you can go on now process your cube database. If you want to process your cube database, you can go on process your cube database. Okay. So like this, and suppose if you thought that even after creating your year-wise partitions, your data is not getting very much fast, then what we can do, we can create a partitions for each month. Okay, for year 2005 data and month of order date equal to January. So for each month, you can go and create a separate partition. Okay, like that you can create n number of partitions. So there is no limit. So I think limit means so we can create maximum I think more than 50 partitions we can create, almost 50 to 55 times partitions is maximum enough for fetching the data very fast. Okay, so it's means it's not required for more than 50 partitions. 50 partition is more than enough to fetch your data very fastly. Okay, maximum 50 partitions we can create. Okay. Maximum means it will allow us, but in real time more than 50 partitions no one will create. Okay. Now let me go for and specify it. So are you able to understand? So here let us say that, so let me take this. So and it's not working. So let me go on process it. Now here itself you can see that how the data is processing. Okay. So processing measure group sales. If you go and see here, so you can see it is processing multiple partitions at the same time. So we have created multiple partitions and these queries will execute parallelly, not separately, not one after the other. All these queries will go and execute at the same time on the sales table. Okay. So if you think that if 2005 year data it is taking, so let us say if it contains 10 lakhs, it is taking 20 seconds. And if you still want to improve the performance, then you can create a separate for 2005 year data. So if it has 12 months data, then you can create 12 more partitions, one partition for each month. 2005 January, 2005 February, 2005 March, like that. If you think your data is still getting some performance, means if you think that your processing time is still, you want to improve the processing time still, then you can go and create multiple partitions until you achieve your required time. Okay. So this is how we can create partitions on a cube database, and you can go on your browser. If you want to browse your cube database, then you can go on browse and you can go on reconnect. If on reconnect, now you can see, so this sale amount, and whenever you are fetching this any query, so let us go on fetch. Now you can see it is fetched the sale amount. Now we can, as usual, we can go and write any dim product category. Okay, so fetching the data means to improve the processing time. To improve the processing time, so we have the partitions. So this data, this sale amount data, will get loaded into the cube database very fastly. Okay. Now, so while creating the partitions, we need to make sure that we have three steps. So while creating the partitions, we have three steps. One is we need to check is, so while creating the partition, let us say, let me create one more partition saying that, so this is your sales table now. Now, let me see, you are creating a partitions like it. So specify query. Now let us say that where sale amount. So we have one sales amount, no? So where sales amount is, now let us say instead of taking the years, you are creating the sales amount field. Okay. So where sales amount is less than 500, is less than 500. So you are creating a partition like this, where sales amount is less than 500. Go to next. Go to next. Design aggregations later. So where sales amount is less than 500. Okay, sales amount less 500. So instead of years, you are creating a partitions or amount fields. Let us say sales less than 500. And finish. And we have, let us say, let me create one more partition for saying that, let us say on sales, find tables. specify rules. Let us say where sales amount greater than 5. Okay, so we are creating one more partition specifying where sales amount is greater than 500. Okay, now let me go and say sales greater 500. Okay, design applications later and finish. Now, so you have written two partitions whose sales amount is less than 500 and whose sales amount is greater than 500. Now, we need to make sure that while creating the partitions, we should not miss any record from the source table. Okay, so what you have done, you have created a partition. Okay, I think my pen is not working. Okay, so we have created a partitions. Okay, like so you have created a partition. So this is your SQL table and this is your SSAS cube database. So we have created a partition for sale amount less than 500. Okay, for getting the sale amount less than 500, and you have created one more partition for sale amount greater than 500. Okay, now while creating the partitions, we need to make sure that we should not miss any record from this sales table. We should not any record from the source table, or let's say in this case it is a sales table. Suppose what I am telling is, suppose if any record is present whose sales amount is equal to 500, whose sales amount is equal to 500, I should not miss that record. No, I should not miss that record. So we need to make sure that in any one of the transformations, any one of the partitions, we have to write whether here or here. So where sale amount is greater than or equal to 500 also. Okay. So while designing the partitions, we should make sure we should not miss any one of the record, any of the record from the source table. And suppose if I write here also equal to, what will happen? So less than or equal to 500 and greater than or equal to 500. So here also, now one more point is we also make sure that we should not get the duplicated data in multiple partitions. So if I write here both sides equal to, then that record will be present here also. So let us say something like order ID like 1, whose sale amount is 500. So that record will be fetched in this query as well as in this query. So you are fetching multiple times the same record, you are fetching multiple times, then your cube database will contain a duplicate record of 1. So we should make sure that we should not get duplicate record, and we should not miss any one of the record. Okay, and to do the partitions, what we have to do, we have to first of all, when you are doing the partitions, we have to convert our table binding to query binding. Okay, so in any of the interview questions, they will ask you how you can create a partitions for the existing measure group. Okay, or first of all they will ask what is a partition and how you will give you are going to create a partition. So, and they will ask you, are you going to create a partition on the measure group or on the dimension tables? So you have to tell them that clearly that every measure group will have one default partition, and when you want to create a partition, multiple partitions, first thing is you have to convert your binding table from table binding to query binding. Okay, that is what we have done for the first one. So we have converted from table binding to query binding. So this is the first step we have to do. And while creating the partitions, we should make sure that we should not miss any record, and we should make sure that we should not get duplicated record. Okay, that is the three things you have to be careful while creating the partition. Okay, understood? So okay, so now I am going and deleting these partitions. Okay, so if you want to delete these partitions, okay, we right click on this. Okay, okay, partitions. Okay, now let me delete this. So let me go for the storage settings. Okay, now you can see it is going for MOLAP. Okay, now let me explain about this. Let me go and delete this partition. Yes, let me go and delete this partition. Okay, I'm deleting the two partitions. Okay, why? Because I will get a duplicated data. So already those 500 records whose sale amount is less than 500 and greater than 500 maybe already fetched the existing partitions. Okay, now so we have one storage settings here. So this is about partitions. Okay, this is how we can create the partitions, and this is how we can improve the performance of your processing time. Okay, so any doubts in this, Kaushik or Abhi? Okay, so now let me go and explain one more topic. So before going to any other topic, let me go and explain some storage settings. Now you can see here we have one storage setting option. No, so let me specify about what is the storage settings. Okay, so for every measure or for every dimension, we have one storage. We have one storage properties. Let me go and see. So if I go to this product dim product, okay, and if I select this, go for properties. So here for right now I am in the dimension, and you can see we have one storage mode option here. So storage mode option, it is specifying MOLAP, ROLAP and in memory. Okay, MOLAP, ROLAP and in memory is there. So three properties are there. Okay, three different storage modes are there for the dimension. Now let me go for cube. Let me go for cube and let me go for any measure group properties. Any measure properties. And here you can see for every measure we have another storage mode here specified MOLAP, ROLAP and HOLAP and in memories. Okay, so for dimension we have storage mode, and for measure we have storage mode. Now let us see what is this. Okay, now let me take storage mode is nothing but, let me see whether my pen is working or not. I have to close it and open it again. Okay, so this is nothing but, let me see what is the storage mode is. So you are fetching the data, no? So this is your SQL data, okay, and you are fetching into the cube database. Okay, you are fetching into the cube database. Okay, you are fetching to the cube database. Okay, so here before fetching, what we will do is, okay, whenever you click on processing, what will happen when you click on processing? What will happen is, so it is going to create, okay, it is going to create aggregations. Why? Because it is, the cube is an aggregated database, no? So the cube contains sum of sales, average of sales, count of sales, count of product. Okay, so first of all it will fetch the data. Okay, it will fetch the data and it will fetch the aggregated data. Okay, it is going to create aggregations on top of that. Okay, it is going to create aggregations on top of that, and it is creating the indexes also. It is going, it has to create the indexes also. Suppose what is this index is, your, for every measure group, for every dimension table, you are creating a primary key. You are making at least one of the column as a primary key. Okay, and for every transaction table like sales table, you should have the foreign key. Okay, you should have the foreign key, and you are creating a relationship. So creating primary key means by default it will create a clustered index. If you create a logical primary key on dimension table, so it will create a clustered index. By default, every primary key will create a clustered index. Means you are creating indexes for your dimension tables also. And okay, so you are fetching the data, you are creating the indexes on top of that data, and after that you are creating a aggregated formulas, aggregated queries, means sum of sales, like that. Okay, now where this data will be stored, that is called storage mode, where you have to store this data. So you are fetching the data from this SQL server, and on top of it you are creating the aggregations, you are creating the indexes. So in SSAS solution, so before putting into the cube database, you are using the SSAS solution. So let us see. On top of that, you are creating a cube database. Okay, let me fetch it. So okay, now let us see. This is SSAS solution. Okay, so let us say this is not a cube database. So let us say this is SSAS solution. Using this SSAS solution, you are preparing a, you are putting the data in the cube database. You are putting the data in the cube database. Okay, so by using SSAS solution, you are fetching the data, and on top of the data, you are creating the aggregations. Okay, you are creating the in SSAS solution, you are creating the indexes. Okay, and you are creating the data. You are on top of the data, you are fetching the data. So where these aggregations, where you are in SSAS, when you are doing processing, no, when you are doing deploying or processing, where in SSAS, where you are storing this data, where your uh, aggregated data is stored, where your indexes are going to be stored. Okay, so the place of this storage will be decided by the storage mode options. Will be decided by the storage mode options. Okay, so we have multiple storage modes like MOLAP. Okay, we have multiple storage modes like MOLAP, ROLAP. Okay, ROLAP. Okay, so we have MOLAP, ROLAP, and HOLAP. So we already see like HOLAP. So what is this MOLAP will do is, so if you set the storage mode as for measure group, if you store the storage mode as MOLAP, okay, then what it will happen is all this data, okay, all this data and the aggregated data. So all this data and the aggregated data. So let me show you. So all this data and aggregated data, where it will store is, it will store in the SSAS cube database site. All these aggregations, all these indexes, all the fetched data will be stored in the SSAS cube database site. SSAS cube database site. Okay, and if I select the storage mode as ROLAP, then what will happen is all this data aggregations and indexes all will be stored again in the SQL database site. All will be stored again in the SQL database site. That is relational OLAP. Okay, this is multi-dimensional. MOLAP means multi-dimensional OLAP. Okay, and this is relational database. Means if you want to store this information in the back in the relational database side, then we have to select ROLAP. Okay, and HOLAP is, this is hybrid. You see, hybrid. Hybrid means the data will be stored. So the data will be stored in the ROLAP side. The data will be stored in the ROLAP side, that is in the SQL database side only, and aggregations and indexes will be stored in the M, that is in the multi-dimensional database, in the cube database. Aggregations and your indexes information, all those indexes will be stored in the cube database side, and data will be still present in the ROLAP side. Okay, in the SQL database. That is the difference between this MOLAP, ROLAP, and HOLAP. Okay, so this is one of the interview questions. What are storage ports? How many different types of storage ports? And what is the actual meaning of them? Okay, MOLAP means whatever you are fetching the data and whatever the aggregated informations, okay, whatever the indexes you are going to create, all those will be stored in the cube database side. ROLAP means reverse. It will be all those information will be stored in the SQL database side, and HOLAP means it is a mixture, hybrid. Data will be stored in the SQL, and the aggregation information, applications you are creating, and the indexes you are creating, all those data will be stored in the cube database. Okay. Then what is the difference? What is the advantages and disadvantages? What is the advantages and disadvantages? So if you select storage mode as MOLAP, if you select the storage mode as MOLAP, everything will be stored in the cube database side. No? So everything will be stored in the cube database side. Then so everything will be stored in the cube database side. Then so this is SSAS solution, and this is your cube database. So if you select MOLAP, okay, so if you select MOLAP, okay, so your aggregations, okay, it will fetch the data. After fetching the data and aggregations and indexes, everything will be stored in the cube database side. In this case, what will happen is, okay, so maybe the processing time, okay, maybe the processing time. So maybe the processing time will take much time. So when you are processing, you are getting the data from SQL database to here, okay, and after processing time, since you are putting the data in everything in cube database side, okay, uh, when you are writing a query, here, means when you are writing the query to fetch the data, since your data and as well as aggregations and indexes, everything is present in the cube database, your query time will be fast. Means your query processing time will be fast. Okay, so when you are going on, I can see when you are clicking on browser, so here it is preparing the query, no? So whenever you are fetching the data, so let us say if you want to see the due date wise, calendar year wise sales, now it is writing the query on behalf of it. It is writing the MDX query. And since everything, your aggregated information and indexes and data, everything is present in the cube database side, now this query time will be fast. Okay, and processing time is getting the data from OLAP database side, means getting the data from SQL table to SSAS solution. Maybe this processing timing, maybe little bit lag will be there, little bit slow will be there, but your query processing time will be very fast. Why? Because everything is present in the cube database. Understood? Okay, so your will the customers will get the data very fastly. If I have selected this storage mode as MOLAP, and this is the default storage port. Okay, suppose if I select storage mode as ROLAP, then what will happen? Suppose if I select the storage mode as ROLAP, what will happen is, so this is your SQL side and this is your SSAS solution and this is your cube database side. Then when you are fetching the data and using this SSAS solution, you are storing the aggregated information. Okay, you are storing the aggregated information. You are creating the aggregations, you are creating the indexes, and you are fetching the data. No, so everything you are storing back in the SQL side by selecting the storage mode as ROLAP, that is relational database. Then in this case, what will happen is when you write a query. So when you write a query on Cube database, so it has to contact the SSAS solution and it has to again fetch it from the OLAP database. Okay, from SSAS solution again it has to contact the SQL database, then it has to send it to this MDX query. You have to send it to this query output. Means in this storage mode, your query processing time will be slow. Your query processing time will be slow, but your processing time, since it is storing the data in the in the SQL state only, the processing time will be fast. Okay, so the processing time will be fast. Why? Because it is storing the data back in the SQL side. Okay, so your queue processing time may be fast, but the queue query timing will be slow in this storage mode. Okay. Why? Because your aggregated information and index information all is present in the SQL side. Okay, like that. Now we have one more storage mode like hybrid. Okay, we have one more storage mode, that is HOLAP. So what will happen is in this HOLAP, so this is your SQL and this is your SSAS and this is your Cube database. So what will happen if you select virtual APIs? So the data will be stored. The data will be stored in the SQL side and the aggregated queries and the index information indexes will be stored in the Cube database side. Okay, in the Cube database side. Now in this case what will happen is when you are writing the query, if you write a aggregated query, so normally 90% cases you will go for aggregated output only, like sum of sales based upon the product wise, year wise, like that, no. So then you are writing the query, your query time will be fast if you are writing a aggregated query. Okay, when you are writing, when we are fetching the aggregated data, then your query processing time will be fast. Why? Because this information will be present in the SQL Cube database set. And when you are trying to fetch the detailed level of data without aggregations, without applications, if you are want to fetch the detailed level of data, then at the time your query time will be slow. Okay, and here since you are storing the data, processing time will be fast. Okay, processing time also will be fast. Why? Because the actual data you are storing back in the SQL database, no? So your queue processing time will be fast, and when you are writing an aggregated query, then your query time also is fast. But when you are trying to fetch the detailed level of data, then your query time may be slow. So that is the meaning of HOLAP. Okay, that is hybrid OLAP. Okay, understood? So this is the different level of storage modes. And in memory means, so in memory means the SSAS solution will have the sub cache memory, no? So if you cube data, if your data is very less, then you can go and select in memory. But usually the cube databases, the data we will be dealing in real time is will be more. So that's why we never select in memory option. Suppose if you think you are creating a very small cube for small amount of data, then you can go and select in memory. So everything will be stored in the SSAS cache memory itself. Okay, okay, understood. So any doubts, Abhi? Can I stop now? Okay. So Abhi, are you there?
Yes, Krishna.
Okay. Yeah, I will send this recording. Okay. Yeah, thank you. Uh, yeah, Ishan, give me 2 minutes. I will connect back again. Okay. Swarna, give us 2 minutes. I will just have to record this class. I will connect back.